So for today, double angle, power reducing, and half angle formulas. Okay, we're going to figure out what these are. We're going to apply all three of them. That's what the objectives are. Okay, I am going to prove some of them, but not all of them. I'd be here for a couple days if I was proving a certain one. So I'm not doing that. But I will prove a couple of them just to show you how you would do it. And then what I'm going to do is this whiteboard, I'm just going to keep all the formulas there. So as I'm proving them on these two whiteboards, I'll just add it onto here so it's there as a reference, because I hate erasing formulas and have to use it so you can't kind of see what's happening. Okay? So these are the ones we've done already. Sum and difference for sine and cosine and tangent. Okay? So now what we're going to do is apply these to figure out what if the angle was doubled? Like what would that be for sine, cosine, and tangent and so forth. Okay? So let's do that. Here we go. So using prior knowledge, let's see if we can find sine of 2 theta. Okay, so what if we doubled the angle? Can we figure out a way to simplify it? Okay, and how I'm going to do that is use the summation formula over there. Okay, so sine of 2 theta can be rewritten as sine of theta plus theta. Because theta plus theta does give me 2. All right. So I'll put over here, we're going to use the sum formula. Okay, so that's the very first one I wrote up at the top of that board. So this is going to look like the following. So it's going to be sine of theta, cosine of theta, plus cosine of theta, sine of theta. Okay. And then if you look, hey, we have the same thing twice. I mean, I know this is flip-flop because of the formula, but they are identical. So there's 2 of them. So this is just equal to 2 sine of theta, cosine of theta. And there we go. So there's our double angle identity for sine. So I'm putting it over here. Put it on the formula board. Sine of 2 theta is equal to 2 sine of theta, cosine of theta. Okay. Let's keep going. Alrighty. So, that was pretty cool. Yeah, write in your notes. Okay, here we go. Do you think we can apply the same method to cosine of 2 theta? Yes, we can. So let's do the exact same thing. We're going to use the summation formula and simplify. So we have cosine of 2 theta. Okay. And again, I'm going to break it down to just theta plus theta. Okay. So using the second formula up there. Now be careful, because we're adding, we're going to use the subtraction symbol, right? These are alternating symbols for this formula. Okay, so this is going to be the following. So cosine of theta, cosine of theta, minus sine of theta, sine of theta. And one of the things, you'll see in some practice that I'm going to give you, because memorizing can be a little tough, but coming up with patterns. So sine, you can see that the signs are the same, they repeat, but the values, they alternate. So sine and cosine, sine and cosine. For cosine summation, the signs alternate, but you see the same thing be repeated for both of those. So cosine, cosine, sine, and sine. All right, so looking at this, we have cosine squared of theta minus sine squared of theta. Awesome. So there's another one. So I'll put it over here. Cosine of 2 theta is cosine squared of theta minus sine squared of theta. But there's
That
more.
looks familiar.
There is more. I don't know if that looks familiar. Apparently it doesn't. Okay, that was in one of your homework assignments. It was one of your problems. I don't know, it was like graded homework, whatever, where you can simplify it further, right? We can use Pythagorean identities to go further with it. So there's 2 other equivalents that you can do with it, okay? So the first one is, I'll put here, you could sub cosine squared of theta equals 1 minus sine squared of theta, using that Pythagorean identity, okay? When you do that, you get 1 minus 2 sine squared of theta. So that's another equivalent. So that's another way you can write it. Or you could sub sine squared of theta as 1 minus cosine squared of theta. And when you simplify, you get 2 cosine squared of theta minus 1. Okay? So cosine of 2 theta has 3 equivalent forms. You could use any one of those, which is great. Okay? So you have some options there. Ideally, you pick the one that looks the easiest to work with in the problem that you're addressing, okay? I'm not gonna say like always use this or always use that, it just depends. Okay. Now, what about tangent? Well, that's gonna be on you. I want you guys to figure that out, but I'll show you what the end result is. It's actually pretty simple.
Proof left to the no.
But there's the formula.
Proof left to reader.
Okay, but again, I'm gonna have you guys try that out for yourself, try to derive it. I believe it's one of the problems I gave you to practice for tonight, okay? But again, you're gonna do the same principle. You're just gonna break it up into theta and theta, plug it into the right formula, and then simplify. Okay, so those are our double angle formulas. Let me box that out. So here they are. And the reason why we're creating these, if you remember using these guys, like sine of 65 degrees, we don't have an angle for 65 degrees on a unit circle. But if we break it apart to 2 angles that do work, then we can start figuring out what these other angle measurements are. Okay, 65 is a bad example because there's not 2 special angles that work for it, but you get what I mean. So this is, again, allowing us to but figure out those angle measurements that are not on the unit circle necessarily, like pi over 2 and so forth. It allows us to evaluate those. And it allows us to simplify some more complicated trig expressions to where we can condense these. All right, let's use it. So given sine of alpha is equal to 5 over 13, and let's say theta is in quadrant 2. Let's find sine of 2 alpha, cosine of 2 alpha, and tangent of 2 alpha. Okay? And by the way, I am, just like I said, I'm going to keep that board available. So only these 2 whiteboards I'll be using throughout the whole entire lesson. Okay, so if you look at sine of 2 alpha, cosine, and tangent, okay, if I look over here, I need to know what cosine of that angle is, no matter what, okay? So what I'm gonna have to do to figure that part out is draw a nice little reference triangle, figure out what cosine is, and then I can start plugging values in and simplifying, okay? So let's do that. Let's create a little triangle. It already tells me I'm in quadrant 2, so I'm gonna draw a triangle in quadrant 2. So let's see, 5's here, 13's here. So I'll just draw, there's our angle alpha, get me to quadrant 2. So I have to find x, right? I gotta find that. You could, by the way, it doesn't have to be an x, you can put an a, a y, whatever the variable is. So I gotta figure out what that is, so I can find cosine of that angle, and then I can start using those formulas over there, okay? So a little bit of Pythagorean theorem. We get x is equal to the square root 13 13 squared minus 5 squared, and we get 12 for that guy. Okay? So it is a Pythagorean triple, if you remember those ones from geometry. Okay, now that we have that, we could start finding these guys. So let's start with sine of 2 alpha. Okay? I'm going to write what this is and then put the values underneath it. So it'll be sine of alpha, cosine of alpha. Okay? So it's going to be 2 times. Now, sine of alpha, we know it's 5 over 13. Okay? Cosine of alpha is adjacent over hypotenuse, that's 12 over 13. But we need to put a negative there because we're in quadrant 2. Okay, so we can put a negative there. Try to put a different color. That's important. So when you're plugging these values in, you got to know what quadrant you're in, so you know what negative, or just leave it as positive, so you're done with that. Okay, so equals 2 times, so this is going to come out to be negative 60 over 169. And we get negative 120 over 169. So that's what sine of 2 alpha is going to give you. Okay? All right, now we got to find the other ones. So let's look at cosine next. So cosine of 2 alpha. Now, I have a choice. I got 3 of those to use. Doesn't really matter. I chose the first one. Again, no really preference of it. So I'm going to use this one. But again, if you use the other ones, you're going to come up with the same answer. So cosine of alpha minus sine squared of alpha. Okay, so cosine of alpha we found, negative 12 over 13 squared minus sine squared of alpha, which is 5 over 13 squared. Okay, let me just pause for a moment. Are we okay with me plugging those numbers in? Right? Just using the formula. Okay, so we get the following. So it'll be 144 over 169 minus 25 over 169. We get 119 over 169. So there we go. So there's cosine 2 alpha. So if you doubled the angle, that's what cosine would be equal to. If you double the angle for sine, that's what it's going to be equal to. Okay. Now we got tangent to go. Now here's the deal with tangent. So look at the formula over there. I can use that. Or I can shortcut it. Tangent is the same thing as sine over cosine, right? So why don't we just use that? So I'm going to put here, instead of using, I'll put double as DBL, double angle formula for tangent. I will use the equivalent, the sine of 2 alpha over cosine of 2 alpha. So I'll just put sine over cosine, okay? So all I gotta do is put these numbers on top of each other to simplify. To me, that's a little bit easier because you already did most of the work there. But again, if you want to use that formula, you can certainly do that. Okay, so we got tangent 2 alpha. I'll rewrite it up here. Okay, so this will be negative 120 over 169 over 119 over 169. And the 169s, they're going to cancel out. So those are gone. So my final answer is going to be negative 120 over 119. So there it is for that guy. Okay. All right. It's kind of like the sum and difference ones. If you remember what we did with these guys, sometimes we had to draw a reference triangle, find the part that we need, find cosine or sine of that angle, and then plug them in the formula. Same pattern here. If I have a missing part, which in this case I did, right? I didn't know what cosine of alpha was, so I had to draw the reference triangle to find it, and then plug the values in. Okay. Questions? Let's continue. All right. angle formulas can be used with other angles besides, for example, 2 theta. Okay? So I'm going to give you some examples underneath it. So we can use the double angle formula in a different way to find some new identities, some new formulas, technically. Okay? And I will say this. I mean, do you see math people memorizing all these formulas and stuff? No. Okay? Sometimes they derive it on the spot because they need it. But if you're working in a certain area or certain context, there might be some formulas that you constantly go back to because it works for that. And when I mean works for that, it means it's easy to use. So like for this one, the reason why I didn't use tangent is because it was easier to use sine over cosine. So something like that. But here are some of the other ones that can pop up. So sine of 3 theta, I can use the double angle formula, and I get something like this. Another one, I could do cosine of 4 theta. If I simplify using the double angle formula, I get something like this. There. Okay, so you do come up with some really cool type of formulas. Some other ones, you can see sine of 4 theta will end up looking like this. And again, I'm not requiring you to memorize it. I'm just trying to show you some other examples. And we'll do one more. Okay. So there's some other ones there that, again, I could derive those using those double angle identities. Okay. So what I want to do, I'm going to show you how to just simplify, how one of these work. Okay. How do I use a double angle to figure out one of these? So I'll do that for an example. So let's try this one. So let's verify that cosine of 4 theta is really equal to 8 cosine of the 4th power theta minus 8 cosine squared of theta plus 1. So let's verify that. Let's actually prove that that really is equal to that. Okay. So we got to pick a side to work with. Obviously, we're going to work with the left-hand side because this is already simplified. We're trying to show that it works with that. So we're going to work with the left-hand side. So let's start with cosine of 4 theta. Let's see if I can't rewrite that a little bit. And I can. Okay, I can rewrite that as cosine. Oh, come on now. Of 2 times 2 theta. Okay. Now, 2 times 2 theta is 4 theta, right? I'm not changing that part. Now let's use a double angle formula. So we're looking for cosine. So right here. Now, notice that none of these have signs in it, so I'm not going to use the first identity or the second one. I'm going to use the last one. So I'm going to go ahead and rewrite cosine of 2 times 2 theta using this guy right here. Okay? So let's go ahead and do that. So we get 2 cosine squared of theta of 2, out of order, of 2 theta minus 1, okay? So if you want to put, let me just put this in a different color. So this is what I used for this guy. So I used cosine of 2 theta equals 2 cosine squared of theta minus 1, okay? So I used that identity for this guy. And now here's the deal. This says 2 times your theta. So what goes here? Theta. So 2 times what my theta is. It's 2 theta. So I just simplified it at that point. Okay, another thing to note. All right, I'll put it right here. That cosine square root of x is the same thing as cosine of x times cosine of x. Okay? So as you can see, I have that situation here just with 2 thetas. So I'm going to expand that out. So this is going to be 2 times cosine of 2 theta times cosine of 2 theta minus 1. So again, I'm just expanding this right here. Let me use that blue again. expanding it using that property. Okay, so let's multiply the middle. Now, this, okay, we know what 2 theta is equal to. It's equal to this guy, right? And again, I'm picking this one out of all three because the right-hand side is cosine, so it wouldn't make sense to throw a sine in there. So now we're going to use this identity again, but twice, okay? So here we go. I'm going to get 2 okay, multiplied by 2 cosine squared of theta minus 1. Same thing. Minus 1 on the outside. I'm out of space. So simplifying what's here, if I multiply these guys out, you get 4 cosine to the 4th of theta minus 4 cosine squared of theta plus 1. Okay, so again, that's just me multiplying those two things in parentheses. Multiply 2 through everything. We get 8 cosine to the 4th of theta minus 8 cosine squared of theta plus 2. And don't forget the minus 1 after. And I think we're just about there, huh? So if you look, if I combine these two, I get my 1, and everything else matches up. So we get 8 cosine to the 4th of theta minus 8 cosine squared of theta plus 1. All right, we did it. Okay. Now again, I'm not deriving all of them, but just to show you the process, because that is something that you're going to have to do down the road to verify one of those. And again, it just depends on the situation. So like these, I had 3 different things to choose from. You just got to find the right one that's going to work for you. And because there's no signs there, I knew I had to use the one with the cosine in it. Yes?
Why can't you just take the cosine 2 theta formula and just multiply it by 2?
Cosine of 2 theta
Yeah,
formula.
cosine 2 times 2 theta, so just 2 times 2 theta.
It wouldn't work out to be equivalent though. Multiplying by 2 wouldn't give me a 4th power, right?
I know, I just didn't know why that is what it is.
Well, we got to be careful because like even if you go back to here, if I had 2 angles I'm adding with sine, that wasn't the same thing as sine of theta plus sine of theta, or sine of alpha, or whatever it is, right? They're not equivalent to each other. Same thing here. Just because there's a 2 in front of here, it doesn't translate as what algebra would. Because trig, you have all the domains to consider, the ranges to consider, you have restrictions, different things like that. So it's not as simple as just multiplying everything by 2, unfortunately. Okay. Now, we got to talk about power reducing. So that's double angle stuff. Let's talk about power reducing formulas. So we can figure out how to take a squared and reduce it just to 1. Yes?
Okay, I'm a little lost. Where did you get the other 2 from? On like the last line.
Here?
Below that. Where did you?
Here?
Yeah.
Here.
Substitution.
Okay. Anything else? Please ask questions. I want you to. Okay. So how can I take a power and reduce it to 1? Okay, a lot of times that is very helpful in mathematics. So how do we do that? Let me show you. So these are called power reducing formulas. Okay? So let's take a look at our cosine 2 theta for a moment. So taking just one of them that they're equal to, okay? Let's say I want to reduce the power of sine. I don't want sine squared. Maybe I want it to be a power of 1. Well, I could solve this for sine to do that. So if I solve this for sine, I would subtract 1 over here, divide by 2, divide by -2, and we get the following. That's sine squared of theta. It's the same thing as 1 minus cosine of 2 theta over 2. So I'm using this, that's not a star, I'm using this to derive this guy here. So anywhere I see a sine squared, if I want to reduce its power to 1, I can replace it or swap it out with this. This is an equivalent to it, okay? So I can do the same thing with the other powers here. So again, not to derive each one, but we get the following. So cosine squared of theta equals 1 plus cosine of 2 theta over 2. And then we get tangent squared of theta is equal to 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Okay? So these guys, got a blue marker here, are called power reducing formulas. So if the problem were to ask, hey, reduce the formula, like, not reduce the formula, reduce the power to just single terms, you could do that with these guys here. And again, these are being derived from our double angle formulas here. Okay? So let's try an example out with that. Let me go back to this board. Okay. Example. Let's write 8 sine of the 4th of x in terms of an expression containing only cosines to the power of 1. Okay? So again, our goal is to take 8 sine to the 4th of x and reduce it to cosines with just the power of 1. Okay, we're going to use those guys at the very bottom to do so. Okay. Now, looking at that, sine of the 4th of x, I can break that apart. Okay, bless you. So watch what I can do. I can rewrite that as sine squared of x raised to the 2nd power. Okay, so those are equivalent to each other. And the h is on the outside because when we're done, we can multiply it by 8. I can reduce this using that formula. So let me go ahead and swap it out. So this is going to be 8 times 1 minus cosine of 2x over 2 raised to the 2nd power. So now I have to handle that fraction being raised to the 2nd power. Okay? So let's do that. So we get 8 times. Okay, so up here I'm going to rewrite it because we're going to have to multiply it twice. The denominator, 2 squared is just 4. So that means that one I can go ahead and simplify immediately. So far so good. So now multiplying the numerator, okay, we get the following. So we're going to get 1 minus 2 cosine of 2x plus cosine squared of 2x. Okay. And then notice that the 8 and 4 can be reduced, so I get a 2. So I can put 2 on the outside. So I did 2 things in that step. First thing I did is I multiplied these out to get the following. And then I reduced the 8 and 4 to a 2. Okay. All right. Now, I unfortunately picked up another power. And they want the power just to be 1. So I got to do something with this. Okay? And I can. So if I look at on the board over there, I know, okay, that cosine squared of theta is 1 plus cosine of 2 theta over 2. I'm going to use that. So let me just put that as a note, a side note over here. Okay, so I'm going to use the following. So cosine of 2x would be equal to 1 plus, no space, 1 plus cosine of 2 times 2x over 2. Now, let me explain that for a second. Over here, looking at the formula, okay, whatever theta is, I gotta multiply by 2 here, right? That's what it's telling me. So if I plug theta in, multiply by 2. So what's my theta here? It's 2x. So whatever that is, I gotta multiply by 2. Okay, so that's what that's saying here. So this will just simplify to 4x when I'm done. So let me go ahead and substitute that in. So we have 2, 1 minus 2 cosine of 2x, plus 1 minus cosine of 4x over 2. Okay? And put it this way. This isn't something that's going to be intuitive at first. It really isn't. When you're looking at that, you're going to be thinking like, okay, what do I do next? And it's going to take a little trial and error, okay? You're going to go down a pathway that maybe doesn't get you to where you need to be. So you have to go back to the drawing board again. Just like verifying identities when you guys were practicing that in like 2 lessons ago.
Anyone is missing a key ring,
So again, just
their AirPods.
not as intuitive to know to use that, okay? But I'm showing you this example. That way you can have your notes next to you when you start practicing. You have an example of it. That way you can use it. Okay, let's multiply 2 to everything. So we get 2 minus 4 cosine of 2x plus. Now if I multiply 2 to this, the 2's cancel out. I just have what's left. So 1 minus cosine of 4x. Okay. And then for our final, that looks like a weird plus sign there. Then for our final answer, I can combine the 2 and 1 for a 3. So we get 3 minus cosine of 2x minus cosine of 4x. Okay, and there we go. So I took 8 sine of the 4x to cosines with only a power of 1 there. Okay. All right. Again, it's something that's very beneficial the further you go with math. There's a lot of cases, especially one of the largest cases would be integration. When you do integration, you come up with different things like this, and you're like, this is hard to integrate. What can I do to simplify it? And it might not seem like you're simplifying it, but you kind of are, okay, to make it easier to use different techniques. So a lot of times, it seems like what we're doing is really unnecessary. And I can see that in your shoes, and I would appreciate, your viewpoint on it. But again, it does help for future things, okay? So, last step is power reducing formulas. That's our last objective. So let's go ahead and, or not power reducing, half angle. I meant to say half angles. So here we go. Using power reducing formulas, we can derive half angle formulas. Okay? And again, I'm not gonna derive every single one. I'm gonna show you how one of them would work. And it's actually very simple. And then I'll just go ahead and write them over there. I am out of space, so it looks like I'm going on the next whiteboard to write down formulas. Oh well, no big deal. So let's try one out. So for example, let's try to find sine of alpha over 2, half angle formula. Okay, let's see if we can't derive that. And again, it wants us to use power reducing formulas. So we're going to use this guy to figure it out. Okay? So let me go ahead and rewrite it. So we're going to use this formula. Okay, so there it is. And what I'm going to do is swap it out for divided by 2. Okay? So let's see what that's going to look like here. So it's going to be sine squared of alpha over 2. And this is going to be 1 minus cosine of 2 times alpha over 2. So again, I'm just taking theta out, swapping out for the value that I want, which is just half of alpha. We get sine squared of alpha divided by 2 equals 1 minus cosine of alpha divided by 2. So 2's reduced out, I just give what alpha's left. And then notice that I want this by itself. There is an exponent. So for my last step, I'm going to take the square root to both sides to finish it. So we get sine of alpha divided by 2 is equal to. Now, because there's a square root, there is a plus or minus there. But we got to be careful in something, okay? I'm going to put this in blue. And I'm going to circle that in blue. The sign will depend on the quadrant, theta over 2 is in. Okay, it's going to depend. So for sine, we know that sine is positive in quadrants 1 and 2, negative in 3 and 4. So if my theta over 2 is in quadrant 3, then I'm going to use a negative symbol. If my theta over 2 is in quadrant 2, where it's positive, then I'm using the positive symbol. So that's what the plus or minus is there for. Not just because it's a square root, but mainly because whatever quadrant you're in, that'll tell you what sign to put out there. So that's very important there. Okay, so let me go ahead and write down, like I said, I'm out of space, so I'll put it up here. And then let's use it. Okay, so here's all the half angle identities. Formulas, I mean to say. We do so many identities and formulas, as words just keep getting swapped in my brain. So here's the one we just derived. Here's tangent. Now tangent has 3 versions. So depending on the situation, you can use any of these 3. And I'll put cosine up here. There we go. Okay, so there they are. Now tangent plus or minus, same thing. That's what goes. But here's the cool part. If you use any of these 2 for tangent, you don't have to worry about the sign at all. So these are nice because the sign doesn't really matter, okay, when it comes to those. That is an alpha. That looks like a weird alpha there. There we go. Okay. Now cosine's formula, you still have to be careful. Depending on where cosine's positive or negative, that's where you start applying those guys there. All right. We got it. All the formulas are there for us now, which is great. Okay, and again, positive note, these are given to you. Okay, they're on a formula sheet. You don't have to memorize those. All right, example. Let's go ahead and use it now. So we want to find the exact values for sine of 15 degrees and tangent of 15 degrees. Okay, so we're going to use those formulas to find those 2 values. So let's do it. So sine of 15 degrees. Now, again, I don't have anything. There's not 2 numbers. I mean, I could subtract 2 numbers. We could use some difference to something. But using half angles, though, that's equivalent to me writing this. Sine of 30 degrees divided by 2. And sine of 30 degrees is something that we do know from the unit circle. So again, you don't want to pick a value that can't give you that. You want to pick a value that works with us and still gives us the 15. All right, so let's use it. Now, think about something for a moment. Sine of 15 degrees, that's in first quadrant, right? So it's going to be a positive value, so I'm going to use the positive version of that formula there. So I'll put a plus sign just for right now. I'm not going to write this plus sign again, but again, that's there because we are positive in quadrant 1 where 15 degrees is. So 1 minus cosine 30 degrees over 2. We'll simplify what's underneath the radical. So again, I'm not going to write the plus sign. So this will be 1 minus square root of 3 over 2 divided by 2. And we're just about done. So let's look at what's here. So this would be what, 2 over 2, right? So if I simplify it, I get the following. So it would be 2 minus the square root of 3 over 2. And then in the denominator, we would have over 2. Now let me make this bigger. There we go. find a common denominator, subtracting it. So this now becomes square root. Now, the 2's here are going to become a 4. So it's going to be 2 minus square root of 3 over 4. Now, the 4 can be a 2. Square root of 4 is 2. So this part stays underneath the square root. 2 will come on the outside there. So there's our equivalent value of sine of 15 degrees. Okay. A lot of square roots there, so you got to be careful with how you simplify. Now, tangent. Let's go ahead and use that one. So we got 3 forms to use tangent. We're going to use the one that I think would be simplest to use. So the one I chose was this guy. Either one would really work, but I chose that one. So let's go ahead and do tangent of 15 degrees. So that's the same thing as tangent of 30 degrees over 2. Using like the same process as sine, because 30 degrees we know what the tangent is at 30 degrees. Okay, so it'll be 1 minus cosine of 30 over sine of 30 degrees. Okay. And I will say, like looking back at the 3 versions, I mean, not that the square root's that much of a pain to deal with, but it's just one less thing to have to worry about. So we get 1 minus square root of 3 over 2 over half. So here's what we're going to do. Because we're dividing by a half, that's the same thing as multiplying everything by 2 in the numerator. This is 2 minus 2 square roots of 3 over 2, which reduces to 2 minus square root of 3. So tangent of 15 degrees is just 2 minus the square root of 3. All right. Questions on how to use the half angles? Yes?
So on the side one,
Mm-hmm.
how did you go from you multiply by 2 in the numerator?
Yes.
No. Why?
Because I got to combine those into one fraction. So this is, I just didn't write the step down. So this is 2 over 2 minus square root of 3 over 2, which gets me to this. Make sense? Yeah. Sometimes, I mean, and again, I don't have a lot of board space, and the more you practice it, you start skipping some steps just to save a little bit of time yourself than to keep writing it. Okay, any others? Okay, I have one final example, and we're done. So let me, I'm out of space again. Am I okay to erase that? No. Okay. We're erasing the formula board. It's gone. That's a bummer. That's okay. No biggie. Actually, all we need is that, so let's get rid of this thing. The formula board almost survived the entire lesson. Almost. Okay. So if we have cosine of alpha is negative 7 over 25, and alpha is in quadrant 3, find the exact values of sine of alpha over 2 and cosine of alpha over 2. Okay. This kind of is like a throwback to the very first example. We had to like draw like a reference triangle in a way. But I don't have to draw one in this case. Okay. I'll show you what I mean here in a moment. So looking at sine of alpha over 2 and cosine of alpha over 2, do you see how you just need cosine of alpha, that's it? So do I have to draw a reference triangle in this case to find other stuff? I don't. Okay, so that part I don't need, but you might have to in the future. If you use tangent, I mean even tangent you can just use cosine depending on that. But again, we have all the information given, so I don't have to worry about that part. But I gotta figure out where alpha is to our alpha over 2. So note that alpha is in quadrant 3, okay? So that's between pi and 3 pi over 2. Okay, so that's where it is currently. But I want to figure out where alpha divided by 2 is going to be located, what quadrant. So, this means that alpha over 2 must be in quadrant 2. And here's how I know. If I divide everything by 2, I can see that pi over 2 and 3 pi over 4, yep, that's in quadrant 2, if you know you're going to circle. So to get from here to here, I just divide everything by 2. So I can see alpha 2 is between those values, therefore must be in quadrant 2. Okay? Now, why do I need to know that? Because I need to know if I'm going to put a plus or a minus sign there, right? So let's look at sine of alpha over 2. I'm going to rewrite the formula here. That way we can see a direct substitution. Okay, now, sine of alpha over 2, sine is positive in quadrant 2, so I put the positive end of it. I'll write it once just so we know that that's why we did what we did over there. So we get 1 minus, so this we do know, so we get negative 7 over 25 over 2. And then we're just down to simplifying that fraction inside of a fraction underneath the radical. So to save a little bit of time, if you simplify the numerator part, you get 32 over 25 over 2. Again, I am skipping a little bit of steps there. You would just make this 25 over 25 and then add the 7. Okay, this becomes, if I take the 2 up there, I get the square root of 16 over 25, which gives me 4/5. Okay, so I don't know what alpha is. I don't know what the angle is, but if they tell me what it is, I mean, I can tell you right now it'll be 4/5 in that quadrant there, given the information they told me. Now, cosine, I gotta do the same thing for cosine of alpha over 2. So I'm gonna use this guy over here, and because we're in quadrant 2, we're gonna use the negative of the formula. So I'm gonna put a negative sign there. Circle it, just so we know the importance of it. So 1 plus cosine of alpha over 2. So if you can see, sine and cosine for alpha over 2 is just going to be almost the same formula, just the sign's different for cosine of alpha, negative and positive. So we're going to get negative square root 1 plus negative 7 over 25 over 2. Okay. Again, simplifying the numerator. We get 18 over 25 over 2. Okay. And then we'll divide it by 2, same thing as multiplying by half. So it becomes 9 over 20. Thank you. Yeah, I'm good. I was looking at my paper here. And we can square top and bottom, huh? So it'd be negative 3/5, finish it. Just had enough space. Not too much, but just enough. Okay. So we did 2 examples. One where it was just straightforward, plug into the formula, simplify. One where I kind of gave you a description of where it's located in a quadrant, and then using the formula, figuring out which one's plus or minus, depending on what quadrant, and going from there. A lot of formulas, a lot of things to throw at you, but this is what we're going to be practicing the next like 3 days. Any questions?